Welcome to this explainer. Today, we're exploring a completely fascinating cognitive trap. We're going to look at how our brains are fundamentally wired to misunderstand probability. Seriously, it's incredibly unintuitive for us as humans, yet this invisible blind spot impacts everything, from how we judge the people around us to the seemingly simple day-to-day choices we make. I'm so excited to guide you through this because I promise you, once you see the math behind reality, you really can't unsee it.
Okay, let's dive straight in by asking you a question from a famously mind-bending psychological experiment by Nobel Prize winners Daniel Kahneman and Amos Tversky. I want you to imagine a guy named Steve. Steve is described to you as a meek and tidy soul. Just based on that super short description, do you think Steve is more likely to be a librarian or a farmer? Take a second and actually lock in your answer.
You guessed librarian, right? Of course you did. His personality perfectly matches the cultural stereotype we all have. But here's the bait and switch. Kahneman and Tversky pointed out that in the United States, there are roughly 20 farmers for every one librarian. There is a massive, pre-existing numerical reality there that we just completely overlooked because, well, we got distracted by a good narrative.
So, the absolutely crucial point here is that your intuition totally ignored the underlying math, what we call the a priori probability, and you fell for a huge cognitive trap based on a stereotype. Rationality isn't just about knowing facts, it's about recognizing which facts are actually relevant. And the most relevant fact here is the base rate, that simple statistical ratio of farmers to librarians in the real world. Think about it. Even if a much higher percentage of librarians are meek and tidy compared to farmers, the sheer overwhelming number of farmers out there means there is still way more meek and tidy farmers in total. In our day-to-day lives, our brains absolutely love a good story. But man, we are just terrible at naturally sensing these baseline odds.
Section 1. A priori versus a posteriori.
Now, these concepts might sound incredibly academic, but they actually go all the way back to 14th century logicians and the philosopher Immanuel Kant. A priori translates to from the earlier. It's a probability that is entirely independent of experience. It's pure math and logic. You know a coin has two sides without having to actually flip it, right? On the other hand, a posteriori translates to from the later. This relies on empirical evidence and observation. So knowing how often it rains in London requires you to actually go out and collect weather data after the fact. Just look at how absolute a priori math really is in these pure scenarios. If you flip two coins, there's a strict 25% chance of getting two heads. If you roll two sixes on a pair of dice, it's a 1 in 36 shot no matter how hard you blow on the dice. Trying to guess a 10-digit alarm code where numbers can repeat? You have exactly 1 in 10 billion possible codes. Math alone dictates these chances, totally independent of any outside events, personal experiences, or our human biases. But here's exactly why this is so unintuitive for us. In our day-to-day lives, we rarely face pure dice rolls. We face messy, complicated situations where our brains really struggle to mix this pure, cold math with our rich daily experiences.
Section 2. Updating beliefs with Bayes.
So, to stop being constantly tricked by our own poorly wired intuition, we rely on Bayes' theorem. This is a foundational formula used in literally everything, from cutting-edge AI programming to basic statistics. Think of it as a process of visualization where new evidence restricts the geometric space of previous possibilities. You start with step 1, your prior. This is your initial a priori baseline, just like that 20-to-1 ratio of farmers to librarians we talked about. Then step 2, you observe new evidence, like Steve being meek and tidy. And finally, step 3, you calculate your posterior, which is your mathematically updated belief based on both the prior baseline and the new evidence together.
This quote right here perfectly captures the absolute core of Bayesian thinking. This mantra is the key to successfully navigating our complex world. When you get a shiny new piece of information, do not throw away the baseline math. Never let new data erase the base rate. You have to update your prior beliefs, not replace them entirely. To see just how wildly unintuitive this is in a high-stakes day-to-day scenario, imagine an investment firm trying to predict a market downturn. Let's say they have a trading alert system that is 85% accurate at catching real downturns. Sounds incredibly reliable, right? If that alarm goes off, your human intuition screams, "Panic! Sell everything! The market is crashing!" But hold on. Look at the top line. The a priori probability, the actual base rate of a true downturn happening on any given day, is only 2%. Because that baseline prior is so incredibly low, it feels completely wrong to our brains. But the math proves that most of the time that 85% accurate alarm rings, it's actually just a false alarm. If you ignore that 2% a priori reality, you are going to make terrible million-dollar mistakes.
Section 3. Navigating uncertainty and risk.
As an investor, or really just as a decision maker in life, researchers have found that you instinctively categorize uncertainty into two distinct buckets. The first is epistemic uncertainty. This feels like missing knowledge or skill. It's a gap in your information, sort of like not knowing the answer to a tough trivia question. The second is aleatory uncertainty. Now, this is inherent randomness. It's a stochastic process, exactly like watching a roulette wheel spin. You simply cannot outsmart the roulette wheel with more data. It's just pure chance.
And our perception of these two types of uncertainty actually drives our daily actions. Notice how the lines violently diverge here as aleatoriness increases. When people view the market as a purely random game of chance, when they feel like they're just at a casino, their personal risk preference entirely dictates their choices. The thrill-seeking, risk-friendly investors jump right in, and the risk-averse investors run for the hills.
So your mental model of the world changes your strategy completely, actively correcting those naturally flawed instincts of ours. If you view the market through an epistemic lens, meaning you think it's like a puzzle that is ultimately knowable, you are going to be highly responsive to information. You'll eagerly spend money to buy financial advice and seek out experts to reduce your ignorance. But if you view the market through an aleatory lens, believing it's inherently random and fundamentally unpredictable a priori, you aren't going to waste time on gurus. Instead, you'll focus on risk management and blindly diversify your portfolio across many assets just to manage that pure chance.
Section 4. Making smarter choices.
The classical definition of probability, championed by the brilliant Pierre-Simon Laplace, demands that we respect the sheer mathematical reality of all cases possible. He called this the principle of indifference. Basically, before making a snap judgment and before letting a highly compelling story or a shiny piece of new evidence distract you, you absolutely must stop and acknowledge the vast landscape of all possible outcomes. You have to honor that base rate. To help build this into our daily routines, we can look at the Smart Choices framework, developed by decision-making experts Hammond, Keeney, and Rafa. They outline a very systemic approach. Define your decision clearly, identify literally all alternatives, evaluate them against clear objectives, and perform a strict risk analysis. Now, why go through all these formal, tedious steps? Because by using structured frameworks, we actively force our fast-thinking, intuitive brains to just pause. We literally force ourselves to look at the a priori math that we are naturally blind to, helping us avoid the cognitive trap of jumping straight to a highly emotional a posteriori conclusion based on limited recent experience.
Which brings us to the end of our explainer. I want to leave you with a bit of a challenge for your daily life. The next time someone gives you a piece of compelling evidence, maybe it's a hot stock tip, a juicy rumor about a coworker, or just a really alarming news headline, will you let your unintuitive brain swallow it whole? Or will you pause, step back, and ask yourself, wait a minute, what was the base rate to begin with? Thanks for learning with me today.